Do you mesh well with others using mesh data in SOLIDWORKS? Welcome to our presentation about working with mesh data. I'm your presenter, Tony Riggs from GoEngineer. We've been getting all kinds of questions lately regarding working with STL files within SOLIDWORKS. There have been several new enhancements in the last few releases of SOLIDWORKS that we wanted to show you and give you some ideas of what you might want to do if you have to work with an STL file. The first thing we need to discuss is where the STL file is going to come from. I've recently worked with a customer that was receiving STL files from someone else that they were working with. He was having to pull that STL file into SOLIDWORKS and use it at the assembly level with regular SOLIDWORKS files. Depending on the file, you still may be able to open the STL file as a solid body, but it will be faceted. That means that the faces are going to be broken up into triangular faces. This will mean that holes are not perfectly round. As an extreme, think of a circle looking like a stop sign. Adding mates and working with the file will be more difficult. If you're going to do this, try requesting a different file type like Parasolid, Step, or a SAT file. Sometimes an STL file is all that they will be able to give you or all that you can find to download. What else can we use an STL file for? You can save an STL file out of SOLIDWORKS to feed into your 3D printer, but some 3D printer software will even bring in the native SOLIDWORKS file, so you might be able to skip this step in the future. What about scan data? That is where the file that we are going to be working with today came from. There may be missing elements from the scan or damage from the original part that we want to get rid of in our SOLIDWORKS model. We're going to look at a few techniques to give you some ideas about what you can do. First, we need to look at some options for opening files in SOLIDWORKS. If we look to the drop-down for the different file types, we will see the STL file listed under the Scan to 3D Mesh file category. This goes with the Scan to 3D add-in that is in SOLIDWORKS Professional and Premium packages. We've had this tool for quite a while to import, edit, evaluate, and create solid geometry from scanned point cloud data and mesh data. We actually want to use the regular mesh file option that lists STL, OBJ, OFF, PLY, and PLY2 for the file types. Once we choose that option, we can click on the Options button for more settings. Under the STL file format, we want to actually choose the graphics body option. We want to double check the units that we want to use as well. We may want to go into the general area and turn off the 3 interconnect option for now. We can say OK and go ahead and open up the file. We can see from the Feature Manager tree that it has come in as a graphics body. Up on the Command Manager tab, we'll use the Mesh Modeling toolbar. If you don't have it, right-click on one of the tabs and turn it on through the tabs directory. We're going to look at decimation of the mesh body. This will help us simplify the facet counts in the mesh body. Decimating can reduce the number of facets, but if we're looking to use the data to build a better model, then I've always heard that you want to use as much of the original data as possible. If we're going to use the graphics body as is, we may want to use this tool to simplify the part. When it comes to reverse engineering, I've always tried to work with as much of the raw data as possible so we don't lose some of the detail in the file that we need. Another useful tool is the Section View tool. We will get a message about only being able to section a graphics body if we have the graphics only section checked. We can still drag around the section plane and look at the section part, and when we say OK, we can see it in the section mode. Another useful tool is the Model Display. When the file is imported, the display style is set to regular shaded mode. If we switch over to Shaded with Edges, we will see all the facets and the graphics performance will start to suffer some. When it comes to reverse engineering and scan data, how do we get started? We're kind of lucky on this part. When it was scanned, the scan data was aligned pretty well with the front plane, and the top plane looks like it's located around the holes on the bottom of the part. Let's imagine that we don't have our part aligned with the planes and see what else we can do. The first tool we're going to use is the Surface from Mesh tool. We have options to help us create planar surfaces, spherical surfaces, cylindrical surfaces, and conical surfaces. If we right click out in space, we've got the ability to paint the selected facets or tangentially select the facets. We can control the size of the paintbrush that we're going to use to go in and select the facets on the side of our graphics body. With this selection, it's going to come in and try to generate a surface on the side of our graphics body. The facet tolerance will control how closely the adjacent facets need to be selected. We don't really need to extend the surface in this instance, but that's an option. And we can come in and hit the calculate button to get us a preview of the surface. But hitting the green check mark will go ahead and create our surface. If we look in the surface bodies folder, there's a surface that was created. On the opposite side, we're going to use the same tool, but the tangent select facets option. The 15 degrees is a little high, so we're going to change that down to 2 degrees. There is the selection that we see, and we're going to go ahead and hit OK and generate that surface as well. Now we're going to use these two surfaces to help us create additional geometry that we're going to use on down the road to continue reverse engineering this part in SOLIDWORKS. It may take a little bit to generate the surfaces, just kind of depends on the quality of the facets that we're selecting. Now we have two surfaces in our surface body and we're ready to go on to the next step. So let's see what we can do here. We've got our two surfaces, but we're going to hide our graphics body to see things a little bit better. With the front plane and the left surface, we can see the angle between them at 0.13 degrees. And then from the front plane to the other surface, 0.14 degrees. So we're not quite parallel. From the reference geometry tool, we're going to create a new plane between these two surfaces, a new mid plane. We'll use that to replace our front plane for additional geometry creation. Rename that plane as mid plane, and then we can come in and select our side surface, start a sketch, and put a point on that surface, somewhere in the middle of the good data. Do the exact same thing on the other side, and we'll use these points here in a little bit. The first thing we're going to do is we're going to do a control drag of our new midplane and use the point on the left surface to create a parallel plane at a point. We're going to come in next and hide our two original surface bodies. We're not really going to use them that much anymore. Show the graphics body once more, and then on that plane too, we'll start another sketch and start generating some geometry. The perimeter circle will allow us to click 3 points on the mesh data. We can see it actually snapping to the mesh data. That'll generate the size of our upper arc. On the side, we're going to draw a line just out in space for now. We're going to add a coincident relationship to the circle, to the endpoint, and then the line to the circle will make tangent. We'll drag the end of our line and snap it to the mesh data. For the bottom, we're not sure if horizontal is really horizontal, so we're going to draw a line just out in space, not horizontal, and then we're going to snap the two endpoints of our line to our mesh data. This will be our new horizontal as we move forward. On the side of our part, we're going to use a 3-point arc to generate that side profile. Click, click, click. And then we've got the ability to come in and add a coincident relationship to the circle and a tangent relationship to the circle. For the endpoint, we can drag it and snap it to the mesh geometry as well. And then to control the radius, we can either do it by eye, or we can come in and add another sketch point to the arc somewhere, and then drag that and snap that to the side of our mesh data. From here, we're going to use the sketch fillet tool, and we're going to come in and add an arc between these 2 points. So if we come in and select the bottom edge and the side arc, it's going to give us a message about deleting the coincident relationships. That's really the relationships where the line and arc are held to the mesh. We can control the radius there. We'll add the other one to the other side. same message. But as we scroll up and down through these radius values, it looks like the 0.7 radius actually matches up pretty well. So we'll go with that. And then with just the power trim tool, we'll come in and make that a nice closed profile. From there, when we go to extrude this, we don't want to extrude up to the other surface, but that's where I add the other point to. We know we want to go up to that point. Now we could have used a mid-plane extrusion. The problem with the mid-plane extrusion is the only option we have is a total thickness for the extrusion. We don't have the ability to extrude up to a point or in multiple directions. So this is a little bit easier to going from one side all the way to the other side. For the bottom notch, I could use the right plane, but it may not be aligned with the rest of the geometry. If we use the bottom edge, start a sketch, create a plane perpendicular to that line, we can come in and draw a rectangle. Now for time's sake, we will go ahead and draw a rectangle even though it has horizontal and vertical relationships on it. We'll be okay with that for now. I want to come in and put a point on each of the side, top, and the opposite side, and we'll use that to snap to the mesh data. Now we could use symmetry to help us align to the other side, but for now we're just going to snap a regular rectangle here. And we'll come in and use the sketch fillet again to come in and pick the size of our arc there. So right at 0.25 inches we've got the ability to line that up, but we can drag on the yellow edge and see how close we are. Looks like 0.25 works for us. We'll leave the bottom hanging out below, we don't really care, but we do need to come back and show the solid body so we have something to cut. We'll do a through all cut in both directions, and then we've got our bottom notch. So far, so good. We'll continue to add a few more features here next. For the side cutout, we're going to come in and use that plane that we just created. We can come in and hide the solid geometry. Come in and draw a line, not vertical, but we're going to draw it off at an angle slightly. From there, we can take a point and put it right there at the midpoint of our line and snap that to the side of our mesh data. We can drag it around a little bit closer and then use a tangent arc to draw the arc at the bottom. Now we're trying to snap this to the mesh data, sort of. We can get it kind of close. Now if we hold down the control key as we're dragging this around, we can avoid actually snapping a relationship. That's a nice tool. So we'll get it close, but not with a relationship. Now we can draw this arc, draw it down a little bit closer, and that looks pretty good to me. We'll use this open profile to do an extruded cut. We have to turn the solid body back on to have something to cut. Through all cut in both directions, except we have to flip the direction to cut. Instead of cutting to the inside, cut to the outside, and then say OK. From there, we can use that new cut and the mid plane and mirror that feature to the other side. We've got another cutout up here on the top of our part. We could draw another rectangle on this flat face and cut it just like we did earlier. But let's take a look and search for something that we need. On our Mesh Modeling tab, there's not a slicing command. This was added a couple years ago. So we're going to type in slicing in our search. If we click on the icon, it's got the ability to start the tool. The eyeball will point an arrow to the tool, or we can drag that icon onto a toolbar and customize it. So with that flat face and the slicing tool, we're going to be able to see how this tool works. We've got a bounding box of what we're actually going to slice. We're only worried about the top of the geometry, so we can rearrange it there. We've got the ability to reverse the direction to go down inside the part. We can control how many planes and slices we want. For us, we're just going to set the value at 2. If we look in at the mesh data, we hide the solid body, we see that some of the mesh data is kind of ugly in that area. So we're trying to find a place on our model where we've got some good information. At 0.13 inches, this works out pretty good. So it may take some trial and error to find the place in our geometry where this works. We're going to turn off the exact option. That would give us a line through every facet. For us, it's going to generate a spline, and that'll work pretty good. We've got options to add the planes and the sketches to a folder. So if we do more than a couple sections, that's really going to help clean up the look of our feature manager tree. So it's going through and it's trying to generate sketches and cross sections through each of those planes. Now the sketch right there at 0, right flush with the surface, we don't really need. So if we come in and hide the graphics body, we've got the ability to see what's going on there. We can actually come in and look in the folder and delete that first sketch. And we also really don't need the plane it was drawn on, so we can delete it as well. But there is the slice at 0.13 inches. If we come back in and show the solid body, let's see what kind of a technique we can use here. Starting a sketch, we're going to come in and draw a rectangle. And we're going to add some relationships. So I'm going to take that line and make it tangent. And we're going to take this line and that spline and make it tangent as well. And then one more tangent on the bottom. And that could work. But let's come in and let's delete the tangent relationship. We've got a nice solid piece of geometry here. Why not use some symmetry? So a center line or construction line right down from the middle of that top edge of our part. And then from that line and the two sides of our rectangle, we'll add a symmetric relationship. Much better. Let's go ahead and throw a dimension on here, 0.628. Make this a nice round number, 0.625. We need to come in and maybe remove some of these relationships and adjust the way we've dimensioned this. The side edge, we're going to remove that tangent relationship. You right click on the dimension and go to the other tab and make it driving instead of driven. And then we'll just type in 0.625. That looks pretty close to the sketch geometry. From there, we'll just do an extruded cut all the way through in both directions and say OK. So that looks pretty good. Now we still got the fillets down there in the bottom. So let's go back in and let's edit our sketch. We can come in and use the sketch fillet again on that point and that point. It looks like the 0.25 inch radius is pretty close. So now looks like we're getting a little bit closer. But how close are we? If we look at the mesh modeling tool, we've got a body compare tool. If we come down here, our source body is going to be the graphics body. And then our body to compare is the solid body. We get a color map of how close we are with the deviation. We can adjust the color settings and adjust the quality. Everything looks pretty good, except we've got some blue areas of the missing features, but also that cutout we just added has got a little bit of a blue tint to it as well. How far off are we? Let's go in and let's take a look at the graphics body. Maybe that cutout isn't quite the same. Let's use the surface from mesh tool again and create a planar face right down the middle of this notch. Maybe the direction needs adjusting. As we go in and say OK to this, we'll see what kind of a technique we can use to adjust the direction of our cut extrude. It's come in and it's created a flat face. We can start a sketch on that face, and I'm going to come in and hide the graphics body to kind of get it out of the way. Draw a line right down the middle of our path there. Go ahead and get out of that sketch. Now we need to rearrange our feature manager tree a little bit to get our parent-child relationships in the right location. So we're going to drag and drop the features down below to reorder things. Then we've got the ability to come in and right-click on our geometry for our cutout and adjust it somehow. So let's see how this works. right click, edit definition of the cut, and in the box right below the through all, we can actually give it a direction. So this almost makes it like a cut sweep. It's not going to be perpendicular to the plane we started on, but it's going to have a path. If we go back into the body compare tool again, we've got the ability to look at the properties and get back into things. And now it's red colored. But what really is that red color? It looks like it's 0.01 inches in tolerance. So that's a little bit tight. We can, lower that to 0.03 or something like that and see what the colors look like. It looks a lot better than it did beforehand. Okay? So we can use the body compare to see where we are with our model. You can see some of the bad geometry there in the middle of those little tabs that we talked about earlier. But now we know a little bit closer where we're at. Let's take a look at some of the other holes and pockets. We're going to come in and use the Surface from Mesh tool again. This time we're going to use the cylindrical option to help us with some of our holes. We can right click and use the Tangent Select Facets option, change the angle to 3 degrees, and with one single click it's going to pick all of the surfaces around that hole. We could go in and possibly extend that surface, maybe use a cut with surface later on, or some sort of sketch relation that's based off of that surface that we've created. Let's take a look at another option. We're going to create an axis that goes through a cylinder, but with the cylinder option we have a paint selected facets now. If we come in and select on some of these and paint down and around this hole, we can rotate it around and paint all the way around 360, and we're generating an average of these different facets around this hole. And we've got the ability to create an axis fairly quickly this way. Now the problem here is each of these options may not be exactly perpendicular to the geometry that we've created. Remember how we had the 0.13 and the 0.14 angle? So those may not be the safest to use unless we're just using them to locate the centers of our circles. So let's take a look at another option. We're going to start another sketch on plane 2, and we're going to draw 2 circles. Not going to snap it to anything just yet, but we might come in and add a relationship between the two. Equal will get us started. That's one step down. They're both the same size. Let's think about design intent. If we hide and show the 2 different bodies, we want to look at the solid body that we've already got. And maybe these are concentric with the arcs we've got on our initial extrusion. If we make those concentric between the arc and the circle, and then we toggle back and look at the graphics body and hide the solid body. If we just drag this out to define the size, that looks actually pretty good. We're going to add a dimension to define the diameter of this hole. And we'll just leave it at that for now. Is that close enough? Probably so. One thing we can do is we've got the ability to change the increment value as we roll the little spinner bar there. So if we want a little bit finer control over the size, we can change that option. If we come in, we can take a cut with these new circles that we've created. We just have to show the solid body again to have something to cut. We can use these holes to help us locate the holes on the other side. They're just going to be slightly larger. So we'll just do an up to next extrusion here, and then the other ones on the other side. It's really a matter of defining the diameter. Okay, so let's come in and look at the pocket on our part. Hide the solid body, show the graphics body. We've done this a few times already. We're going to come in and look at what's the best way to do this. The data inside the bottom of that pocket's kind of ugly. We can do a surface from mesh, another planar surface. But where we paint here, we got to be kind of careful around this bad geometry. We may have trouble to get it to actually generate a nice flat surface if the deviation is too far. If we hit the calculate button, it will give us a preview here in a little bit of the flat face. Now when we go in to make this cut, what are we going to do? Well, we don't really maybe want that to be an angled face. So let's generate the surface and then use it to help define the depth of our cut. So on that surface, we can come in and start a sketch, and we're going to draw a point kind of in the middle of where we kind of saw that good data, because that may be at a different angle. From there, we're done with that. We can hide that surface that we've created, and there's our point. On plane 2, which is out in space a bit, we're going to come in and we're going to draw our pocket. We're just going to snap it to some geometry there. I'm kind of going off of that inside edge. I'm trying to be consistent with my assumption as far as where this is located. So I'm just snapping it to the geometry there. Up here, you can sort of see it. It's a little hard to see. There's that line right there. Snap it there. And I'm going to use the sketch fillet again to connect the dots. That line to that line. Again, the message that we saw where it's breaking that coincident relationship where it's snapped to the mesh data, we're fine with that. I'm just going to add 4 radiuses in the corners and say OK. So for my depth of my cut, I'm not going to extrude up to the surface that I created. I'm going to extrude up to that point. That will give me a nice flat bottom to the cutout that I'm creating. Up to that vertex right there. And we can say OK. We're going to come in and start the regular fillet feature. And we can either select on the edge around the perimeter, or we can just select the entire bottom face. Put a 0.1 inch fillet around that pocket, say OK, and then we can come in and select those 2 features and mirror them about our mid plane and add the pocket to the other side. Looks pretty good. And come back and change to shaded with edges. Maybe get a better look at our model. If we come in and clean some things up, hide some of the planes, hide some of our sketches, we're going to come in and turn on the original mesh data and take a look at how it compares. One more surface there around the hole. So we can see the facets in our mesh body. We could go ahead and do a body compare one last time to take a look at the differences. A few more holes, maybe a chamfer or fillet here or there to make everything line up a little bit better, but it's looking pretty good as far as I can tell. So I hope this video gave you some ideas about how you can use mesh bodies to create a nice parametric solid body that we can use. Maybe we're reverse engineering an older model that we don't have the CAD data for, or we're documenting the shape of a part that we want to improve. There are so many tools inside SOLIDWORKS for us to try. You may just have to get creative with your techniques. If you can master some of these techniques, then we can say that we do mesh well with others. So this was Tony Riggs with GoEngineer, and I hope you enjoyed this video.